a workshop on history of ecological economics and theory of natural capital. Well, today we have planned to start with the presentation of our dear Nathalie Berta. Unfortunately, she has written to us with the bad news that she will not be able to participate because of health problems. So we are going to start with Marvin Dupuis presentation titled Controversies on the Valuation of Global Natural Capital. He's first year PhD student. His university is Paris 1, Panthéon-Sorbonne, more especially the Centre d'économie de la Sorbonne. Well, his PhD deals with the concepts, metaphors, methods, and ways of thought that circulate between economics and ecological science. In this framework, he wrote in 2021 a master thesis entitled The Concept of Natural Capital, Trojan Horse or False Impact of Ecological Economics, a historical and methodological approach, 1972 to 2000. This Saturday, he will focus on a short part of a short historical period of ecological economics, the two controversies between 1997 and 2000. On first, the ecological footprint of Mathis Wackernagel and William Rees, and two, the monetary valuation of world's ecosystem services of Robert Constanza in 1997. He will introduce them in detail and show how they are important for the history of the current and what can be learned from them. So if you would like to start, Marvin, it's on you.
Yes, thank you very much, Victoria. So hello, dear colleagues. Thank you, Professor Fraggio, for this great conference. So for this presentation, I will focus on the history of ecological economics between 1997 and 2000, when the concept of natural capital is already predominant. I will introduce two controversies on the valuation of global natural capital that took place at the same time. So in introduction, the concept of natural capital re-emerges in 1988 with David Pearce from the London School to incite conventional growth theorists to work on environmental issues and to resolve theoretically the sustainable development promised by the Brundtland report. The emerging school of ecological economics immediately reappropriates this concept to build its own identity. One quite consensual definition is an aggregate stock of biophysical features that provide use and non-use benefits to humans through a flow of ecosystem services provided over time. The stock depletes if the annual consumption exceeds the flow. And the young ecological economics support in majority strong sustainability, so the preservation of the biophysical value of natural capital, but it's already a pluralist school that wants to deal with global environmental problems and natural capital valuation. And in 1997, these two objectives converge with two papers of figureheads, Wackernagel and Rees, estimate the biophysical value of the stock required to support the global economy, it's the ecological footprint, and Costanza et al. Estimate the monetary value of the flows of the available stock. They will generate intense debate, notably in two special issues of the journal Ecological Economics in 1998 and 2000. And these controversies will deepen intern disagreements. So I will dedicate one part to each controversy and then examine which lessons can be learned from them. So first, the controversy on the ecological footprint, EF. EF is best known for its temporal translation. It's the Earth Overshoot Day, on which humanity consumed the entire annual flow of its natural capital. So first, the paper, Wackernagel and Rees, they developed this concept in different papers along the 90s. But the 1997 paper is the culmination of this work. For them, monetary value cannot reflect at all a lot of the biophysical stock. they suggest land area as an alternative metric. They will define the carrying capacity as the natural capital available in a nation, and ecological footprint as the natural capital required to support its living standard. So it's the aggregate land area needed to produce the resources it consumes and the waste and to absorb the pollution and waste it emits. The idea is that each unit of matter and energy consumed has required a certain amount of land in one or several types of ecosystems, such as forest for paper. They detail the calculation of ecological footprint in their book of 1995. 5 types of goods are considered. So it's food, housing, transportation, consumer goods, and services. And also 6 types of ecosystems: artificial surfaces, gardens, agricultural surfaces, grasslands, managed forests, and the last one is called energy land. It corresponds to the land area required to provide the energy contained in a good. So for low carbon sources, it's the footprint of the production units. And for fossil fuels, it's the forest area required to store the CO2 emissions without distinction between oil, coal, and gas. Their calculation is presented in table 1, and it gives an ecological footprint per 100 gigajoules consumed each year of 1 hectare for fossil fuels, and of 10 to 400 times less for low carbon sources. So these values are therefore approximated to 0. So the composition of the energy mix, fossil non-fossil ratio of a nation gives us the ecological footprint for the ecosystem energy land per unit of energy. The calculation takes place inside an ecological footprint matrix. It's table 2. It's a double entry table in which the footprints are added up ecosystem by ecosystem or good by good. And you can see that fossil fuel represent the largest part of the total EF, with 2.3 out of 4.3 hectares for an average Canadian. Consequently, in table 3, on the bottom left, you see that carbon and ecological footprints of different nations are well correlated. And for the authors, land area is a good indicator of natural capital because one, it's proportional to the biomass production of ecosystems, so it's scientifically rigorous. It also insists on the finiteness of the planet. And thirdly, it's a good guide for action, just like the Kaya equation for CO2, because they say, I quote, as the EF of humanity needs to be smaller than the available carrying capacity, it becomes an absolute benchmark. EF can be reduced through lower population, lower consumption, more efficient technologies, or higher ecological productivity. And in their paper of 1997, Wokernagel and Rees show that all rich nations have an excessive ecological footprint between 2 and 5 hectares per capita, while the global carrying capacity is 1.5 hectares per capita. The national scale shows this sustainability gap, and it's as if nations which overuse their natural capital exported their excessive EF to the other nations, which must bear them in addition to their own ecological footprint. The table 4 distinguishes between rich nations with an ecological surplus like Canada, sorry, it's this table, like Canada and Australia, and with an ecological deficit. And the international trade is considered as partly responsible of the depletion of natural capital because it raises competitiveness as the only objective, so that the overshoot of the local limits is encouraged and hidden. Now, concerning the reception, after the publication of the paper, EF is anonymously recognized as a powerful concept regarding heuristic power. But it also receives many critics. In the special issue of Ecological in 2000 are invited some figureheads of this school to give their opinion. And we can easily distinguish two camps, opponents and supporters to EF. Opponents are Robert Ayres, Moffat, Upshur, Von Kooten and Bulte, Dutch, and also Herendeen. And supporters are William Rees, Wackernagel and Silverstein, Template, and also Rapport. And only Costanza has a nuanced position. They all insist on the fact that ecological footprint is a great media success, as it's now used in ministries, educational games, and NGO advocacy. The consensual explanation for this success is the surface metric and the single number result that manage to capture people's imagination and to motivate them. Now, concerning methodology, many problematic omissions are noticed by opponents, like exported environmental degradation, like water for agriculture destined to be exported, equity, inter and intra-generational, also intangible natural capital features like biogeochemical cycles regulation, also mineral resources that are non-energetic, problems with the equivalencies between ecosystems, the role of ocean is absent, the possibility to decarbonize energy mixes, and also other pollutants than CO2 like CH4 or NO2 and 2O, and finally, future trends in technical progress and ecosystems productivity. But for the supporters, these limits show that ecological footprint is a lower bound, so it's useful. Now, opponents notice also some economic and ecological risks linked to self-sufficiency, to autarky, like the exploitation of primary forests or the replacement of food by resources that are not accounted in the calculation, like metals or subsoil resources. And they suggest instead to create a trading market between nations with high ecological footprint and low carrying capacity, and nations with low EF and high carrying capacity. But supporters argue that nations with low ecological footprint and low carrying capacity, like for example Egypt, would lose out in such a system, and that international transport has its own high ecological footprint. For them, nation is a good scale to collect data and to try to coordinate environmental and economic policies. Now, opponents after also notice reasons why EF would be a bad compass tool for policy making. It's for them scientifically unfounded, static, also excessively aggregated and narrow. For some of them, it's neo-Malthusian. It hides the social unacceptability of CO2 terrestrial storage. There are choices about equivalencies between ecosystems that are not explicit, that are hidden, and it doesn't prescribe anything concerning concrete institutional reforms. But for the supporters, EF provides a clear and accurate message, and crude and simple information would be sufficient for public action. And William Rees explains that. He says, the survival of any population depends ultimately on the availability of adequate ecosystem support, regardless of the political regime or prevailing socio-cultural values. And finally, EF was designed as, he says, an ecological camera and not a prediction tool. Finally, we can mention the nuanced position of Costanza. It will enlighten the second controversy. For him, deciding requires always simple comparisons, and we already do that every day. Aggregation does not generate information loss, and international trade is not yet but may become sustainable, so that EF stimulates fruitful debates and a plurality of indicators will always be needed. Now, the second controversy on the monetary valuation of global ecosystem services, Costanza, he began his career as a tropical ecologist. He's a figurehead of ecological economic, an historical advocator of strong sustainability. But in 1997, he publishes a paper in Nature signed by notably Darge and De Groot, in which he attempts to aggregate the flows of natural capital on a global scale and estimate its monetary value. Ecological footprint is has historically rejected this kind of approach, which is there taken to its climax, we could say. Concerning the paper, the authors first explain that the artificial reproduction of natural capital would have an infinite cost, and that destroying it entirely would bring human well-being to zero. So they reject weak sustainability and argue that natural capital stock should be at least partially preserved. However, there are for them several reasons to evaluate ecosystem services in monetary terms. It's emphasizing the need to preserve it in another language than the slippery slope of morality. It's paving the way for future improvements, helping the policymakers in their choices, and replicating what is already done to human life in public investment projects. So to estimate the marginal value, welfare impact of the depletion of the global natural capital, they begin by compiling 100 local estimates of the willingness to pay of people to protect an ecosystem in order to get the surfacic marginal value of each ecosystem service. They use figure 1, which shows the supply and demand curves for a manufactured and substitutable good, it's in 1A, and for an ecosystem service, according to them, in figure 1B. So in 1A, you see that the value that would appear in GDP is area BPQC. The production cost is CBQ, producer surplus is PBC, and consumer surplus is ABP. The total economic value is the sum of the surplus, so it's ABC. And in figure 1B, the production cost of an ecosystem service is 0. The non-total substitutability that they make as hypothesis between natural and man-made capital for each type of ecosystem, it results in a demand curve that is asymptotic at 0. And at this case, consumer surplus and total economic value approach infinite value. And as supply is supposed independent from demand, the supply curve is vertical. Then, depending on the data available for them, they use the total economic value, ABCQ, or the area PBQC, which is here both the producer surplus and the product price quantity. And then they multiply the surface obtained by the global area of each of the 16 types of ecosystems considered. It's table 5 with, as you can see, many missing data. And the sum of these 16 values is between 16 and $54 trillion with an average value of $33 trillion. So they interpret it as the annual cost of doing without global natural capital's flow. And GDP would have to be increased by this amount, so tripled at this time, to keep living standards intact. And the author anticipate critics and list some omissions of their work. So certain ecosystem services are missing, like deserts or croplands, the informal economy, future increases probably in willingness to pay and the threshold and irreversibility effects in the supply and demand curves. They conclude, like did Wackernagel and Rees for the ecological footprint, that their value is a lower bound. Now, concerning the reception, the media success of the paper is immediate, as shown on this quotation. And in 1998, Ecological Economics proposed a special issue and brings together positive reactions and critiques of several figureheads of this school. So we have this time many authors who do both elogy and critiques. So I suggest three camps to describe this controversy: opponents with Rees, Norgard et al., Thoman, Turner et al., and El Serafi, but also supporters with mostly notably Pimentel and Herendeen, and nuanced position with Hermandali, Ayres, and Hutting et al. Concerning positive reception, some authors believe that all attempts to reveal human nature interconnections are welcome, are good to take. That an infinite value is no more operational and useful to save natural capital than zero value. That shouting in dollars is not always counterproductive and allows to be listened, to be audible by other economists and by southern countries whose aspiration to growth is high and legitimate. And that the result that they found legitimates strong sustainability because it proves that natural capital would be the limiting factor of development. Concerning the methodology, the authors explain that the study suffers from several limits, like uncertainties linked to aggregation, of course, but also double countings of some ecosystem services, also included in the GDP, segmented and static calculation that ignores irreversibility, confusion between ecosystem services and ecosystem functions, and between the value of natural capital and the cost of its preservation, and therefore questionable curves for supply and demand, as shown in the figure 2 that you have here, taken from El Serafi's paper, which proposes, instead of the figure 1b, a family of demand curves, and for the supply curve initially at 0, and that starts to increase when the ecosystem service becomes threatened. Now, regarding usefulness for policymaking, many authors consider that the indicator is too aggregated to be useful for more than a simple comparison over time, because it does not show specific protection needs and also the global decline of biophysical value and the distribution of the impacts of this decline on the populations. So it gives also the false impression that the economic criterion is and should remain the only criterion for policymaking. And also they point out that the indicator can be misinterpreted in the media, like Dali explains. So I quote, a reporter called me and commented that we are a lot richer than we thought and must think carefully about what should we do with the extra wealth. He identified public wealth with the sum of private riches. Now, concerning ethics, the study is seen as a renunciation by Costanza of the anti-utilitarian values promoted at the birth of ecological economics as a first step towards the commodification and privatization of the environment, and a break with the idea of strong sustainability that the size of the economy would be constrained, embedded in the biosphere. And so it's also an abandon of questions of equity, as we said, promotion also of a Western-centered and panoptic vision, like Norgard et al. Say. So I quote, "Will ecological economists bring us the value of God next? And will that be the end of history for economic valuation? Or now that we know the exchange value of the earth, we wondered with whom we might exchange it and what we might be able to do with the money without earth." And for them, it's also an example of a manipulation of science for policy influencing, because they write, I quote, "The paper coverage was implemented by Nature through advanced circulation of the article to key science journalists and editors of other journals. Is science being staged and manipulated in order to receive press attention? Would the authors have published their findings if they had determined that the value of nature's services was only half of GDP? And what does it mean when scientists have to write articles with ever more authors to gain credibility? Does it make sense for ecological economists to capture the short-term gains of being among the leaders or not? And as an answer to all these critics, Costanza and his co-authors, they repeat their initial arguments, and they explain that their study complements but does not replaces anti-utilitarian approaches, that their aggregation in the article is not more problematic than in GDP, that ecological footprint failed to, what is important for them is to compare the value of ecosystem services lost with the value of economic services gained, and that some recent studies have shown that the monetary value of ecosystem services is proportional to net primary productivity, and therefore that it doesn't hide any information. Now, thirdly, which lesson can we learn from these controversies? For that, I suggest first a quick detour through an enlightening analysis of the aggregate indicators of the Anthropocene by French ecologist and philosopher Vincent de Victor. In his 2018 paper, he explains that the notion of Anthropocene transforms our representation of environment and makes it global, close, conquested, retroactive, exponentially degrading, and doomed to an uncertain future. Its graphs and indicators manage to sound the alarm by allowing to put the Earth on ordinate and time on abscissa to follow its evolution. However, he says aggregation is not trivial or natural, but it results from choices to sort, to order, to select information so that it distorts biophysical realities. He says there is no unifiable nature in a simple variable such as temperature, CO2 concentration, or a global observatory for the state of ecosystems, fauna, and flora. Thus, the idea of climate change results for him of a vast machine. So it's a socio-technical system that collects data, models, theories, that is fed by observations, seen as raw materials, and transformed into knowledge by a network combining expertise, technology, politics, but also mass media and civil society. And similarly, for the idea of biodiversity crisis, talking about a global vertebrate species richness and abundance has required the aggregation of data from a variety of taxa, of methods, of countries. It results in a data diversity that erases the singularity of the field survey, and biodiversity was initially localized, heterogeneous, subjective, complex, and interactive, and now it becomes global, homogeneous, neutral, simple, and juxtaposed. Moreover, for him, data acquisition programs have for origin and purpose a political agenda of enunciating desirable trajectories and also identifying the responsibles. De Victor thinks it's the manifestation of what he calls a panoptic order, utopia dating back to Francis Bacon, which sees the Earth and humanity as interacting totalities, and Earth as an object that can be driven by humans after overhanging external observation. So De Victor talks here of a strategy without a strategist, an extension of the biopower of Michel Foucault to the environment. So I think our two indicators studied in the two first parts of global natural capital fit perfectly into De Victor's description. It's Earth from space, as announced already in 1989 by the subtitle of the journal Ecological Economics. What is criticized in Mokernagel and Rees, and also in Costanza et al. Initiatives, is precisely to have subscribed to this panoptic vision and therefore pursued a political agenda, but also to, at the same time, to have refused to provide any concrete example of action. And Costanza explains that the controversy starts when one moves from simply stating the result of the ecological footprint calculation to interpreting it as an indicator of something else. And concerning Costanza's initiative, Rees also said that commensurability engenders the belief in total substitutability and fakes long-term security. But we can see that none of them identified in their own work the problems that they had seen in their mutual work, because we can say that Costanza's initiative also raises interpretations problem, and that ecological footprint also suggests a commensurability, but now inside natural capital elements, and maybe more than in Costanza's paper, because here the hypothesis was a non-total substitutability for each ecosystem service. So also both indicators show the limits of strong sustainability, because Costanza wanted to demonstrate it, but was accused to pave the way to incite to weak sustainability, and Wakernagel and Rees wanted to postulate strong sustainability, but may have, regarding their critics, discredited biophysical valuations. And the indicators were built to mobilize citizens, but they can as easily demotivate them if they are wrongly interpreted. They reinforce a technocratic vision of crisis solving and a refusal to study historicity and conflictuality of environmental management, like Maria Kerman observed it. And moreover, in their book of 2014, French sociologist Bruno et al. Talk of a statactivism, which is a statistical innovation spread by a network of indicators that of innovators that correspond to new ways of thinking and to organize social relations. So it's a way for a minority to fight with numbers in order to make its claim heard audible. So I think our two indicators meet all these conditions, all these criteria, and that's why we can say that they were accused to be misguided forms of environmental statactivism. And in 1998, Costanza said he has just synthesized already existing informations, but both indicators create actually a new knowledge, and its media success can contribute to hide other knowledge more rigorous and more relevant for policymaking that has been aggregated for this new knowledge. So even if they appear as rival indicators, I think that it's actually two sides of the same coin regarding the critics received, the coin of the belief that policymakers are pilots that can correct the trajectory of the biosphere, of the society, if they receive a simple message in dollars or in hectares. And Clive Spash in 2013, he suggested that after these controversies, three camps in ecological economics can be distinguished. So he call them new resources economics, which deals with new environmental problems such as climate or biodiversity via the standard neoclassical tools. Also, the ecological and social economics, which is frontally opposed to it and advocates to get nearer from heterodox schools like Marxism or institutionalism. And finally, the new environmental pragmatism, which focuses less on the theoretical debates and more on the capacity of academic work to become audible for policymakers in order to influence action. And consequently, for Gail Plumcock and Quentin Quix, Costanza et al.'s paper, and more generally, the primacy given to the monetary approach valuations in the journal Ecological Economics show a victory of this camp of new environmental pragmatism against the two others. However, it seems to me that Wackernagel and Rees could be also included in this trend, and that biophysical valuations can also be done within this logic of pragmatism as easily as monetary valuations. More generally, in his analysis of the critique of GDP, Antonin Potier explains in 2018 that alternative indicators will not allow any more than GDP to drive the economy, as because GDP is only a macroscopic resultant of microeconomics decisions. And he explains in the following quotation that political rationality and economic rationality are two distinct things. So I quote, in the best case, the socio-economic calculation is a language of negotiations which does not determine the outcome. And in the worst case, it's merely an argument of authority that covers the arbitrariness of the political decision with its supposed naturalness. And a new indicator will certainly change the socio-economic calculation, but not the political rationality behind public investment decisions, and would not have a major effect. So according to Potier, the emergency for economics is rather to submit, to propose to the public debate some proposals of actions that might effectively manage to align the trajectory of the society with the improvement of such new indicators. And as Carly and Skappen says in 1998, and as shown more recently, initiatives such as the one of the World Bank in 2005, where is the wealth of nation, measuring natural capital for the 21st century, and also the Natural Capital Project in 2011 of Gretchen Daly, the valuation of natural capital has developed significantly over the last 25 years in the institutional field. And this has legitimated ecological economics. And thus, the two controversies that we have studied and this new environmental pragmatism can be seen as actually a struggle to obtain the hegemony for prescription inside and also outside ecological economics, even if it has implied for consequence to blur even more the internal coherence of the school, and to divert it from what is maybe also very important, like social, institutional, and anthropological dimensions of the environmental crisis. And this is precisely the thesis of Maria Ackerman. So, in a nutshell, this tendencies that I described is not necessarily specific to ecological economics, because in their paper of 2014, Hirschman and Popp-Berman argued that the quest for political influencing concerns actually all the fields in economics, because the success of economists is often, as they explained, determined by their ability to ally themselves with powerful and resource-rich actors, as well as by the favorability of political institutions. The consequence is therefore the development of a, as I say, penchant for quantification, for developing devices for seeing and devices for choosing, a desire for professional authority, and the tendency to do normative choices that remain invisible to non-experts and to define a policy issue as essentially technical. They explain it's even more the case, this tendency, in time of crisis, because the uncertainty opens up space for ideas to make a difference. And so this enlightens again the origin of our two controversies in the framework of the environmental crisis. And to get out of this tendency, Antoinette Beaujard in 2018 argues that to be socially useful, economics need to articulate positive, normative, and realistic dimensions, and to propose modest and partial, but rigorous and transparent valuations that can, after that, be complemented by other works from other methods, communities, and disciplines based on other values. And in this way, economists, for her, so especially ecological economists, will manage to find the right balance between the synthesis and the rigor of the information delivered to policymakers. Thank you.